Now we're going to look at moles and using various conversion factors to go from moles to grams, grams to moles, or other things as well. There are three major conversions that you'll be using in chemistry. One is moles, between moles and mass. This is going to be determining the gram formula mass, so you know that 1 mole of anything is going to be equal to the gram formula mass of that compound. So for example, we learned in an earlier video that 1 mole of water was 18 grams of water. And we got our 18 grams by knowing that we had 2 atoms of hydrogen, each at 1 atomic mass unit, 1 oxygen at 16, and add that together and you'll get your 18. So we'll review over that as well. A second one we talked about before was dealing with moles and particle number. This is when you're going to use the Avogadro's number, which is 6.02 times 10 to the 23. This is equivalent to 1 mole of any substance, and we typically use this in relation to either atoms if you're dealing with a single element, or molecules if you're dealing with a compound. And I just use MC as an abbreviation for molecules. Finally, you have between moles and volume, you know that 1 mole of anything is going to be equal to 22.4 liters of a substance. The only stipulation when you use this particular conversion factor is that it is only under certain conditions at standard temperature and pressure. So we'll talk more about that later on, and we're just going to assume for right now that we are at standard conditions so that we can make use of this particular conversion factor. But later on when you do gas laws, you may have to make some other stipulations and some other changes in order to use that particular conversion factor. So we'll start off with the grams. So if we have a certain number of grams, in this case 25 grams of sodium chloride, and we want to convert it into moles, then the first thing we've got to do is determine our number of each atom. So we have 1 sodium, we have 1 chlorine. We'll multiply each one of these by their atomic mass. So this is 23. If you look it up on the periodic table, this one is 35.5. Again, off the periodic table. If we add these together, it's going to be 58.5 grams. What that's telling me is that in 1 mole of sodium chloride, I have 58.5 grams of sodium chloride. So I'm going to use that as my conversion factor. I'll start off with the 25 grams they gave me, and then set up a conversion so that I put my grams on the bottom. So my 58.5 grams that we just solved for as the gram formula mass will go on the bottom so that those will cancel. My 1 mole will go on the top, and then the rest now is just doing the math. So I just simply take my calculator, say 25 divided by 58.5, and I'm going to get a 0.427 moles of sodium chloride. If we do the same thing for the second one, we know that we have 2 hydrogens, each at 1, so that's going to give us 2. 1 sulfur at 32 is going to be 32. And then 4 oxygens at 16 is 64. If I add 64, 32, and 2 together, I'm going to get 98. So that's telling us that for 1 mole of sulfuric acid, I have 98 grams of sulfuric acid. So that's my conversion factor that I can use. So I'll start off with the 125 that they gave me. Put my grams on the bottom, so that'll cancel. That's my gram formula mass. That's equivalent to 1 mole, which will go on the top. And then now the rest is just plugging into your calculator. So I'd say 125 divided by my 98, and I would get 1.28 moles of sulfuric acid. If you look at the last one, this is the formula for a hydrate, so we're going to talk more about that one a little bit later on. But basically, if you're getting the gram formula mass of this little dot in here is more like a plus sign, not like a multiplication sign like it is in math. So basically what you'll do is you'll get your gram formula mass for this part, and then you'll add 5 waters, which would be 5 times 18, to get your total gram formula mass. So we'll look at that one a little bit later on. Now if we go the other direction and we want to start off with moles and go to grams, then, let's see, I gotta back up a little bit. Somehow I got off here. We'll start off with this first one. So we know that we already figured out that 1 mole of sodium chloride was equal to 58.5 grams of sodium chloride. You're still going to be able to use that conversion factor. It's just we're going to use it in a different order because our moles is on the top now instead of our grams. So we'll take our 2.5 moles of sodium chloride. This time we want to put the 1 mole on the bottom and our grams on the top. But we're still using that same conversion factor. So the mole units will cancel, and now we'll simply be taking our 2.5, multiplying it by our 58.5, and that's going to give us our grams of sodium chloride. So it'll be 147.53 grams of sodium chloride. If I do the same with my sulfuric acid, we knew that 1 mole of sulfuric acid was 98 grams of sulfuric acid. So again, I'm going to use the same conversion factor. I'm going to start off with my 0.5 moles of sulfuric acid. 1 mole on the bottom this time, so that the mole units can cancel. 98 on the top. And I'll get 49 grams of sulfuric acid. If we do moles and volume, remember this one, we have a conversion factor of moles is equivalent to 22.4 liters. We're assuming we're at standard temperature and pressure. So we're just going to do one of these real quick. So on this one, if we do our moles of oxygen, we have our 3.2 moles of oxygen. Our 1 mole again is going to go on the bottom so that the mole units can cancel. 22.4 is going to go on the top. So I'd multiply 3.2 times my 22.4, and I'll get my 71.68 liters of oxygen. You would do the same for each of these, just using the same conversion factor. Now let's look at one like this. This one's a little more difficult because now we got to combine 2 things that we've already done. You're starting off with grams, so we'll do this one here, the one with oxygen first. And we want to get to moles. And then we want to get to volume. So in this particular case, if you don't start off with moles or you aren't going to moles, you're going to have to take whatever you're given. In this case, we'll take our grams, convert it into moles by using our gram formula mass, and then we'll convert it into liters by using that 22.4. So we actually have to do 2 steps here. So the first thing I would do is get my gram formula mass for my oxygen. So I have 2 oxygens, each at 16, so that's 32. So that's telling me that for 1 mole of oxygen, it's 32 grams of oxygen. So that's going to be the conversion factor between the grams and the moles. So I'll start off with my 100 grams. I want my grams on the bottom so that that unit could cancel. My mole on the top. And then I will use my other conversion factor where I know that 1 mole of anything is equal to 22.4 liters. So this time, since I'm looking for liters, I'm going to put the 22.4 liters on the top, the 1 mole on the bottom so that that can cancel. And now the rest is just plugging in my calculator. So I'd say my 100 divided by my 32, and then times my 22.4, and I would get 70 liters of oxygen. So this just requires a little bit more work because you aren't starting with moles, you're not going to moles, but you're going to convert whatever you have, in this case grams to moles first, and then moles onto liters using another conversion factor. So let's look at one more like this. So if we have our 10 grams of ammonia, we have 1 nitrogen, is it up here, times 14. And we have 3 hydrogens times 1. So its gram formula mass is going to be 17 grams. That's telling me that in 1 mole of the ammonia, NH3, I would have 17 grams of ammonia. So I'm going to take my 10 grams, put my 17 grams down here to my 1 mole. That gets rid of the gram unit. And then if I want to go on to liters, I know that in 1 mole, I'll put that on the bottom so the moles will cancel, is equivalent to 22.4 liters. And now the rest is just doing the math. So I take my 10 divided by the 17, multiply by 22.4, and I get 13.18 liters of ammonia.